Welcome everyone to the 2024-2025 Speaker Series, hosted by the Forum for Equity in Elementary Mathematics. I'm Cynthia Colon, your host for this evening. We'd like you to know that today's webinar is being recorded so it can be posted and shared on the Forum website. We would also like you to know that we have reserved some time at the end of the presentation for questions. You can submit your questions throughout the session via the chat box to the Q&A host. Before we begin the presentation, I'd like to introduce to you a little bit about the Forum. The Forum for Equity in Elementary Mathematics is a web-based resource hosted at TERC in Cambridge, Massachusetts. TERC is a nonprofit organization whose mission is to improve math and science education. As part of its mission, TERC is committed to modeling how diversity, equity, and belonging can improve STEM education and research practices in order to create and support inclusive learning environments and equitable outcomes for all. The Forum grew out of a long-term TERC project, Investigations in Number, Data and Space, a K-5 mathematics curriculum funded almost 35 years ago, in part by the National Science Foundation. While the Forum is informed by our decades of work on investigations, the professional development related to it, the Forum is not curriculum specific because equitable teaching and learning applies to every classroom in every school, regardless of the adopted curriculum materials. The Forum for Equity in Elementary Mathematics, launched last fall, is intended to be a place for educators to reflect on and discuss equity, access, identity, and agency in the K-5 mathematics classroom. Its goal is to provide resources, publications, and professional learning opportunities to broaden and deepen perspectives, to open up discussions among educators who are pursuing equity in mathematics learning for their students. One such resource, which is guiding much of the work, is a framework for reflecting about equity in elementary mathematics classroom. This framework identifies 4 areas for consideration when reflecting on equity in mathematics and considering action at the classroom and school level. These 4 areas are deep and rigorous mathematics, equitable participation in a collaborative mathematics community, strength-based assessment and accommodation, and connections to students, their families, and their communities. This year, the speaker series is organized around these 4 areas. In tonight's session, Dr. Rachel Lambert would emphasize the importance of trusting all students in their mathematical abilities and believing in their potential to succeed. She will demonstrate how educators can create environments that encourage mathematical sense-making for every student, focusing on the creative work that makes math more accessible and inclusive. Through real-world examples, Dr. Lambert will highlight how teachers can honor and embrace the diverse ways in which students think and learn, fostering an atmosphere where all students are trusted, valued, and empowered to thrive as mathematicians. A little bit about Dr. Lambert. She's an associate professor of special education and mathematics education at the University of California, Santa Barbara. Prior to her academic career, she spent over 10 years as both a special education and general ed inclusion teacher in New York City, San Francisco, and Los Angeles. Dr. Lambert's research focuses on how students of color with disabilities develop identities as math learners, the role of emotions in mathematics, and the application of universal design for learning in math education. She's also deeply engaged in exploring neurodiversity in mathematics. Her work aims to increase access to meaningful math experiences for all students with disabilities. Please join us in welcoming Dr. Rachel Lambert.
All right. Really excited to be here and to talk to you about trusting all students as sense makers. So I think Cynthia just went through some of the most important things about me. I was a teacher. I was a special ed teacher. I was a general education teacher. I taught in various places and got my doctorate because I was very fascinated by what I was being told about students with disabilities learning meaningful mathematics by research. I felt like the research was telling me that the students that I cared so much about, that I loved teaching, my neurodiverse students, my students with disabilities, those students couldn't think deeply and meaningfully, and I knew that was absolutely and completely and categorically wrong. And so that's why I got my doctorate, and that's my research really focuses on that. And that particular question, how can research support teachers in enabling, showing, accessing the mathematical brilliance of disabled and neurodiverse kids? So that's really what I am super passionate about, and I hope you learn about it today. I have a book called Rethinking Disability in Mathematics. And the cover there is a bunch of different teachers in different places doing work with kids that are covered in the book. So I also have a website where you can find lots of different resources, things I'll talk about today. I make sure to share those, and I share all my research, public access on the blog to make sure that people have access to it. So I wanted to share this screenshot from the first session from this forum. I'm really excited that I got asked to be part of this forum because I have had a relationship as a teacher with Turk for a long time. I used Turk curriculum in 1999 when I first started teaching in New York City, and I loved it. And I've always respected so much the work that goes on at Turk, and I love what they're doing now, and I've loved the speaker series. And here's the question that I sort of wanted to focus on. So, how do we establish and support equitable mathematics learning communities in which students, especially those who've been historically underserved, develop positive identities and agency, make sense of mathematics, and know that their ideas are important and their voices are heard? I think this is such a critical and important question, and I think too often students with disabilities are not considered in this way. We think about where their achievement is. We don't think about their sense of agency. We don't think enough about the sense that they make of mathematics and that their ideas are important. And that's why I call this trusting all students thinking, because sometimes the students who are the hardest for us to trust is students who might take a little longer to think, who might think in complicated ways. And those are the students who we're going to talk about how to support those students today. So first I want to talk briefly about the problem. Like, what am I setting up as the problem? Well, I'm going to start, as I often do, with the voices of people with disabilities. So this adorable youngster is Seamus Young. Seamus is an adult with dyslexia and autism, and he's writing in an online memoir, or a memoir you can buy, about his experience learning math in schools. And he wrote, "Math is hard because of how boring and time-consuming it is. Homework usually consists of doing the same problem 40 times in a row. Then tomorrow we will do 40 more of the exact same problem, except with one extra digit of complexity thrown in. The pages march by, an endless procession of mind-numbing paperwork, a treadmill of uninteresting problems. What I fail to understand is that the harder classes are where math becomes far more interesting. Instead of 40 dull problems, they give you 5 interesting ones. Instead of pointless drills, you can begin to see how to use math as a tool. They finally give you a pile by 2x4s and let you start nailing things together." Think about that quote, and I'm going to give you one more quote to put in relationship to it. This is Chanel. Chanel is a Black woman in a research project. She is, I think, about 20 or 21, and she's featured in this book by David Connor called Urban Narratives, Portraits in Progress. So in the study, he interviewed over time 8 different students of color who had experienced being in special education at the New York City public schools. And their narratives are fully printed out in this book, so you can learn a ton about them as in their complexity. So she was talking about special education math classes, and she wrote, "In math, they don't give you a chance to do it on your own, to succeed, to see if you know how to work it out. They'll just tell you real quick. They don't even give you a chance to think about it. And they'll show you how to do it. Yeah, but they go through it fast, and they do it again too easy. They find the problem all out for us." Oof, I love that last part. So both of these are kind of incredible quotes about what it feels like to learn math. Seamus is actually talking there about being a student with dyslexia in the gen ed classroom, where Chanel is talking about being in a special ed classroom, but there is similarities across what they're saying, right? So what is the problem from their point of view? I hear that they're not allowed to think. I hear that they are given work that is boring. I hear they're not being allowed to make connections between mathematics and their world. And that it's a lot of drill and a lot of replication and a lot of procedures. And that's how their math education is. And we can understand why kids then disconnect from mathematics or don't use it to make sense. But let's talk about it from a different point of view too. So with students' point of view, can give us one view of the problem, and these are 2 specific students, right? But let's look at it from a systems point of view when you often talk about test scores. So we're going to talk about test scores just very briefly. And over in the, I don't know my right from my left, left side of the screen, you have the percent of students who are below basic on 2013 NAEP data. And first I'm going to show you data for white students. And so for students who are non-disabled and who are white, in grade 4, 6% are below basic. And that grows to 12, it grows to 21%. Now I'm going to show you data for white students who are disabled, who have an IEP or 504 plan in schools. And we can see immediately there is a tremendous difference. That just having a disability means that their test scores in math are extremely different, right? And some of these students are going to need extra support in learning mathematics and would even in the greatest school system in the world. And some of these students would not. Some of these students have all the ability to become mathematics professors in the world, but they're obviously in context in which their sort of gifts or talents are not being shown. And now I'm going to show you data for African-American students. So first, non-disabled students. So this is clearly there is a problem. And the problem becomes excruciatingly, painfully clear when we look at data. So when we look at African-American students with disabilities, at grade 12 in 2013, 94% of them were below basic. What we are looking at here is a systemic problem, right? Not an individual problem, not each individual kid. This is a systemic problem that's creating these. So the problem, also another way to think about it is what I hear teachers say. I hear, those aren't my kids. She's not ready to be in my class. She doesn't know her facts. I wasn't trained for this. Students with disabilities can only learn from explicit instruction. Don't give them multiple strategies. It confuses them. They have too many gaps. I hear that tools like a hundreds chart, I once heard was a crutch. It was a crutch to give that to a student, to allow a student to use it, and a lot more. And these are artifacts of the way that we have been trained to think about both mathematics and disability. So what we need to do is to rethink disability and to rethink mathematics, rethink them together in order to change the situation for students. So one big, huge answer is to trust their thinking, just trust the thinking of all of these students. And this was written by Susan DiMatteo. She's a fifth grade special ed teacher. She writes, "Trust has been my key to becoming an effective math teacher. I trust that my students have the ability to make sense of math. I trust they'll arrive at the understandings they need at their pace. Trusting my students has empowered them. In my classroom, students know I will not be coming to the rescue at the first sign of trouble because I believe in their own abilities. When they get stuck, I redirect them back to themselves. What do you know about numbers that can help you? It's hard, they tell me. Yep, you figure it out, and eventually they do. They do because through my trust, they trust themselves. We need to empower students to trust themselves. And this is exactly what I think I hear in Chanel's quote particularly. She didn't feel that she was trusted to think. And that's what teachers like Susan, an amazing special ed teacher, is able to do for her students. She's in chapter 1 of the book if you want to learn more about her. She's really cool. So the big ideas for today are that disability and neurodiversity are not the problem. Inaccessible and old-fashioned math learning experiences are the problem for those students. And the great thing about that is it's fixable. When we think about it as a systems problem and not an individual kid problem, we can fix those problems. It's not easy to fix them, but we can fix them because they're not inherent within the kids. And we're going to talk a little bit about UDL math, which I see as a way of thinking, not like a checklist, like, oh, I did this, multiple means of representation. I think of it as a creative way that educators solve problems. And we're going to meet a teacher and her students. So as we do all this work, I want us to remember that disability is complex. Disability is never just one thing. Many people, for example, with autism, often also identify as having ADHD. Every single person with a disability is also a gender, is also race, also has a certain set of experiences learning math. So everybody's complicated. So if anybody tells you that there's one way of teaching math that's going to work for the complications of disability, which is an extremely complicated category, I don't really trust that, right? Not one way is going to work. Not one method is going to work. There's no trick that's going to fix you, except the trick is trusting all students thinking and doing the other things that you learned in this series. Disability comes from all the rights we have in schools, like the 504 plans come from disability rights protests. You can learn more about these by watching my favorite documentary, Crip Camp. And the inclusion and sort of the laws that we have around disabilities have only come because people with disabilities have fought for them. 504 plans came because people with disabilities did a 26-day sit-in in a federal building in San Francisco in 1977, the longest occupation in history of America. And they did not leave until they agreed to sign the 504 plans so that they could have access to buildings, so that kids with disabilities could have access to schools. So you just have to remember it's always been a fight. And so it's hard work, including everybody. It's hard work changing things. It's hard work changing systems, but it's been a fight for a long time. I use both person first language and identity first language today and every time I talk, because person first language is, some people with disabilities prefer that. And disabled people, that's identity first language. And some people with disabilities prefer that. So I first became a teacher using, one of the Turk units I actually used, name that portion, in my 5th and 6th grade classroom in New York City, in which I had 24 kids. And most years I had 8 or 9 students with IEPs in my classroom, or 504 plans. I also used the work of Kathy Fosno, Constructing Fractions, Decimals, and Percents, that book. This was before the curriculum existed, so I had to kind of write my own curriculum. And I also was heavily influenced by the work of like Judy Storygard, who works at Turk and was one of the forerunners of writing materials for teachers that trust in how kids think, all kids think. So I really want to establish that and how important these things were, the bedrock for what my ideas. Universal design for learning is a really important idea that is often presented as a checklist, but I think of it, and those I'm doing research on UDL math and teachers, it's more of a mindset. It's more of a way of thinking. It's more of designing towards accessibility. And then we're going to see an example of that today. So we, in our research, when we've studied teachers who are doing this, what we notice is that they're doing 3 things. They are noticing and challenging deficit thinking about students. They're noticing and challenging the barriers that exist in classrooms for students, and they're creatively redesigning classroom practices, spaces, and systems towards inclusion. I can never, like, people ask me, oh, what should I do for this? What should I do for that? I'm like, wait, stop, think, do an empathy interview with a student, meet in a collaborative group, and problem solve, because you are the experts on your kids. You are the experts in the situation. Disability is complex, and I'm not going to tell you one way is going to work. I'm going to lean on you to develop confidence in your ability to creatively problem solve, because it's that creativity that's at the heart of it. So in this process that I talk about is first noticing barriers. Math class is too narrow, opening that up, trying to figure out ways that we can make it more flexible, more open, get more kids participating. And then lastly, sometimes that's not enough, so we have to put in strategic supports. So I use these gestures all the time with teachers. They actually came out of the gestures that teachers would use when I would teach them about this, when we would have conversations about UDL and math, and they're like, it's like math classes like this. We need to, we need to pull it open. We need to open it up and make it more accessible to more kids. So let's dive into the story of how a teacher did this. So this is about a teacher named Miss Ray and 2 of her students, Oscar and Daniel. And you can see her here. These images that are throughout are stills from our video that one of my grad students, who's an artist, turned into sort of these comic book strips so we could get a sense of the bodies of the people we're talking about when I didn't have permission to share. So before we do it, I need you to do a little bit of math to think. So get ready, get a piece of paper. And I want you to solve these problems and think about, not how, well, okay, don't solve them. Wait, slow down. I gave bad directions. I want you to think about how 5th graders would solve these problems. There's a 5th grade teacher that I know that when she would give a problem like this, especially a problem with fractions, she would say to the students, if in doubt, and they would all yell back, draw it out. So that is my advice to you. If you're not sure how a 5th grader who's just learning about fractions would solve it, I want you to draw it out. So the first problem is that Sam's family has 8 children. So you should be solving it. You don't have to listen to me if you don't want to, but I'll read it out loud in case somebody wants to hear it. Sam's family has 8 children. For dinner one night, all 8 children plan to share 6 large burritos. If they share them equally and don't throw any away, how much burrito will each child get? I have 12 cans of paint. It takes 3/4 of a can of paint to paint 1 chair. How many chairs can I paint? All right. I think that was the longest minute in the history of the world. It's so hard to wait. I had to make myself, I wrote down the time that I was going to give you. So hard to wait. It's so hard to wait, especially on Zoom. I'm not a good waiter on Zoom. All right. So I hope you have some ideas and some drawings of these 2 kinds of problems. So in this book, which is one of my absolute favorite books about teaching math, Susan Empsey's and Linda Levy's book, Extending Children's Mathematics on Fractions and Decimals, It's incredible. I love it so much. They talk about different kinds of equal sharing tasks, and they talk about three kinds of these tasks. One is an equal sharing problem, partitive division. So here's an example of that. I have 10 blocks of clay. She needs to split up the clay between 4 students. How many blocks of clay will each student get? So that's students usually sort of partition it out, just like they do in division, but sometimes they draw, they break up into parts, little fractional parts, and then they put them back together. A multiple groups problem is a multiplication problem. So say I have 4 students and I want to give each student 2.5 blocks of clay. So I think of those as chunks and I'm putting them together. And the third is a multiple groups problem. So that's measurement division. So it's division, but not a partitive problem, but a measurement problem. So now I have 10 blocks of clay. I want to give each student 2.5 of a block of clay. How many students can I provide with clay? So here's a chunk of 2.5, chunking it 2.5, 2.5. So if you could in the chat, which kind of problem are each of those problems? Is it an equal sharing problem? So the one about Sam and the burritos and the kids sharing it, is it an equal sharing, a multiple groups multiplication, or multiple groups division? And the second problem is about a chair. We know how much we know that she has 12 cans of paint, and 1 can of paint paints 3/4 of a chair. How many chairs can she paint? So will you put in the chat your answers? So yes, the Sam's family one is an equal sharing problem. So kids are going to break it up into different sized chunks. Multiple groups problem, the measurement division, 12 cans of paint, breaking it into 3/4 the size of C. So you're going to see kid strategies for these 2 problems. So it is well worth your time that you just thought about this mathematically, of course, as it always is. But one of the students in the study I'm going to talk about, name is Kalani, and here's her work for that first problem. And what I notice about this work is that here's the first way she solved it. She took the 6 burritos. Well, first she drew circles for all the 8 kids. You can't see that, but they have little people. Oh, they have number A, B, C, D. They're letters. And then she splits them into halves, and she splits the leftovers into fourths. So she ended up giving a half plus a fourth. The second problem, she did it another way because she's extra and she's amazing. And so she took all of the burritos and she split them into fourths, every single one into fourths. And they got a fourth plus a fourth plus a fourth is 3/4. And then just because she is extra, and now you believe me, she just decided to start musing on the side of her paper that 1/8 equals a half of 1/4, which must equal 5/10 over 4, which equals what? That's how extra Kalani is. All right, so in this study, I did this study with the collaborators when I was at Chapman University at the time. So Trisha Sugita, Catherine Ye, who's now at UT Austin, Jessica Hunt, who was at North Carolina State, and Shane Brophy. And what we did was we looked at one classroom for a year. We looked at the classroom, had an amazing teacher, Miss Ray, who we really wanted to see her inclusive teaching practices. Like we wanted to study a teacher who was pretty amazing at this work. We decided to focus on 8 students, 4 girls and 4 boys. 3 of them had IEPs. Some language students were also multilingual learners. And what we did was first we collected data on their engagement. So we were looking at how a teacher increases participation of students. So the first thing we did was collect data on student engagement. So for 3 days, we like took all the data. We videotaped small groups and whole group, 3 consecutive days. And we also interviewed all the focus students. Then we did a lot of analysis. Then we presented it to the teacher and we showed her our data on participation. We asked her what would she do about this. And then she implemented sort of her intervention. And then we collected data to see if participation shifted and interviewed the students again at the end. So just so you can understand a little bit about her classroom, it was an amazingly warm and welcoming 5th grade classroom. She had a focus on sense making. She would generally start with like an opening number sense routine, like a number string or a notice and wonder or a which one doesn't belong, something like that. And then she would usually do a CGI story problem, like those problems where she would give one problem and give them 35, 40 minutes to solve it. So they had lots of time to solve it. They usually worked by themselves first and then worked in groups, but she didn't actually control that. She let them decide if they wanted to talk to their partners or talk alone. She gave them a lot of freedom in this classroom. And things that I heard her say all the time is mathematicians take time. Do you want to change your thinking? At the end of the lesson, she'd say, what was our favorite mistake today? What mistake helped us learn something new? And then she would draw a heart next to the favorite mistake, and they would all go, ooh, which was really, really cute. But one of the students in her class, name is Oscar. Of course, it's not really his name because it's a research study. He has autism. This was his first year being mainstreamed into a mainstream class. He had been in separate self-contained classrooms, being like going out for math class, for example, he did before, but he hadn't been all the time in a gen ed classroom as he was this year because Miss Ray fought for him to be in the class. He loved science. He loved real world problem solving in math. And his IEP said he was nonverbal, which was inaccurate because he was verbal. He just didn't talk a lot. And Miss Ray described him as shy, which I find a really wonderful non-deficit way to describe someone who just doesn't talk as much as other kids. So when I asked him what he does when he's stuck in a math problem, he paused in an interview. He paused a lot before he responded to things. He took his time to think. He said he just keeps on trying the problem. And he had areas of strength in whole numbers, and he was really just being exposed for the first time to fractions at the beginning of 5th grade. Another student I want you to think about is Daniel. Daniel was Latino. He was more fluent in Spanish than in English, and he had an IP for a learning disability, which was really dyslexia. He was having trouble decoding in 5th grade, and he was well behind his peers in terms of his decoding. He loved soccer. He had a strong friendship group. He would speak Spanish and English, Spanish at home, and socially, like he would speak Spanish. His knowledge of math was very inconsistent because he had not had consistent schooling up to this point. And so he knew some things and didn't know other things. On problem solving, when I interviewed him, he told me, I think what I can do first and what do I need, and then I start. 2 kids who were not focused students, but you already met Kalani. Remember, I told you she was extra. We saw her strategies. She was an amazing student who would always just listen and think and engage and do extra strategies and talk to the person next to her. Noel sat next to her, and he loved mathematical discussion, and he often had to be told to let other kids sort of talk sort of subtly. And one other kid that becomes part of the story is Toby, who was a Black 5th grader in the classroom, who was basically known by the class as being the strongest in math, perhaps him and Kalani. And he loves sharing strategies. He loves engaging with other kids. When he would finish the problem, he would just walk around and work with other kids on the problem. That's what he liked to do. So here's Daniel's work for that first problem. Daniel was the student with dyslexia, who was a multilingual learner. He had one side of his paper had this strategy. And you can see page 1, the first thing that I notice is that he has 8 burritos and 8 kids. So he's miscounted or just switched the numbers or sort of lost track of what he should be when he was drawing. And so he partitions it, but he kind of stops, doesn't seem to know exactly what to do. The second part of his paper has a strategy where he's splitting it in half and then splitting it in 4s, much like Kilani's first strategy, and has a nice equation down there. And this part, I want you to remember this when we talk about what happened in the classroom. So here are those kids in their classroom. And Miss Ray poses the question. They start working. Daniel looks up for a while at first, which he typically does. He sort of looks around. And then Kalani solves it pretty quickly and solves it another way pretty quickly. Oscar keeps working. So he starts working, he keeps working. Miss Ray comes over and asks him, how much of a burrito does each person get? And at this point, Toby comes over and starts talking to Daniel. Toby and Daniel are working together. You'll notice that Toby is holding the pen at this point. And Kalani and Noel are talking about the part in her paper where it says 1/8 equals 0.5 over 4, 5/10 over 4. So they're having this kind of deep conversation about this little thing she put in her paper. They stop talking. Daniel and Toby are still deep in conversation. Oscar has still not talked to anyone, but he's still working. He's trying new strategies. Kalani ends up coming over at the end and sort of talking to him about a strategy very briefly, but he doesn't engage with her. And so here is from our research what we looked at in their engagement. So We have the work time. So it's just 11 minutes of work time I just went through with you where they're solving the problem. And Oscar, the blue means they're working independently. So the white means they kind of looked up and looked around, and the green means they're talking with somebody else. So I want you to think first about what you notice about these patterns of engagement for these students. So remember that we have Oscar who's working very hard, but not talking to somebody. So at the very end there, Kalani's talking to him, but he's not really talking back. We have Daniel, who doesn't start as soon as the other kids do, but then engages in this conversation when Toby comes over. If down there in the box, it says total small group utterances round one. That is when they are told to turn and talk. That's how many times they talk to each other in turn and talks for 3 days. Oscar talked once, Kalani talked 79 times, Noel talked 103 times, and Daniel talked 38 times. So what are the barriers here? I show this data to Miss Ray, if I showed it to you, what would you consider to be the barriers for participation for Oscar and Daniel? And what would you do? And you can put that in the chat. So I didn't show you any of Oscar's work, but he doesn't, in this case, come up. This is in the beginning of the year in the fall. And remember, he's just beginning to learn about fractions. And he doesn't get to a right answer in this. Although he does some very beautiful thinking and partitioning, and he keeps retrying it, but he doesn't necessarily, like what he needs is a conversation with somebody else, which is what Daniel gets. So when I showed this data to Miss Ray, she didn't see a problem in Daniel waiting and starting. She definitely didn't see a problem in him collaborating with somebody else to get an answer. She didn't see that as cheating. She had no problem with it. She was like, that's wonderful. I love that. This is an interview with Daniel and Toby that I interviewed them afterwards, and I asked them about it. I didn't get it, so he helped me explain it. At the very end, I asked Daniel, what helps you about being with another kid when you get stuck? Their thinking. They share their thinking, but not the answer. Is that true for you? And Daniel says, if they give us the answer, I'm not learning anything. He was like, obviously, Rachel. So he ends up talking to me more about why he purposefully waits before he starts. He imagines the problem and he thinks about the problem. He needs to think about it here first before he thinks about it on the paper. And I love that that flexibility is already existing in this classroom. She does not force them to get started. There's no time on task. It's like, if that's what works for you, that's what works for you. But for Oscar, she was concerned. She felt that him not having community and having conversation was a problem for his mathematics because everyone else was getting a chance to change their answer, to check it. So what she decided to do, first she talked to the entire class about what discussion meant. Because she said it wasn't just like getting Oscar to talk. It's about getting the whole class to talk to Oscar. Because she doesn't see that it's his issue. It's the group's issue. They didn't look at him. They didn't talk to him. They didn't necessarily, maybe they were nervous to talk to him, but they didn't. So she gives him this problem. And oh, you just saw, please ask questions. Please send questions in. Any question. I can't wait for questions. All right. So she gives this. So this is like months later. This is in March. And the first one was in the fall. So here's the second problem that we solved. And here's Oscar's strategy. We're going to watch it a couple times, so don't worry. I'm going to ask you to think about it. All right, you saw it once. Now you get to see it again. This is me redrawing it and making it into a GIF or a GIF or a whatever you call it. All right, so here's his actual work. And I think you could see there that he is breaking, he made this giant box. First of all, most kids made the 12 cans. They would draw a square for all 12, but not Oscar. He's like, he actually managed to draw a big box and then partition it into, oh my gosh, how many squares? That's really beautiful ratio thinking, isn't it? Like to be able to like figure out the spaces. So he does it in a big box, but he's still doing the 3/4. He still has 12 boxes of 1/4, right? And then he does he puts them in as a group, 3/4, 3/4, 3/4, 3/4, 3/4. And then he has to count his 3/4. and he miscounts. So he initially writes down 17 shares. Oh, I'm pointing at it. You can't see what I'm pointing at. No, he writes 17 and you can see it's crossed off here. So what happens in the classroom? Well, first of all, they've changed groups. So there's different kids here. And another part of the intervention, Miss Ray, was she wanted to put him next to a student named Bob, who was a very quiet student, who was very thoughtful. And she thought they'd be a great match because they were quiet and they could sort of talk quietly together about their ideas. So they're both working. You can see Oscar looks at Bob's work, which is really nice, but they keep working independently. And then, so you can't really see this, but that's Miss Ray's hand coming in. So she's basically like, they're both done, and she pushes their papers together and gets them to talk. She's like, oh, look at this. And it turns out they actually both got 17 as an answer. So now they're deep in conversation. This is a great situation. They have the same answer. And like, she's like, oh, let's talk about it. And Bob then starts, someone across the table is like, that's not the right answer, or says it's 16. So Bob gets involved. Oscar's watching super carefully as they talk it out. What is it? He changes his answer. And Miss Ray comes over and says, she says, will you guys share together? And will you share your change in thinking? She really wants them to share how they had one answer and they changed it to another. And as she starts, she does something really interesting. She says, I have his permission. She tells the whole class, because I think the class knows that Oscar is shy, and she does not want them to think for a second that she's putting him on the spot without his permission. So she's really respecting his agency here. Like she will not put him on the spot. I just love that. I love that. So they end up sharing. And at first, Bob's sharing. But the questions kind of shift over to Oscar. And what's kind of amazing here is this is her chart paper. And that first one, because Bob started explaining it, it's those individual squares. Oscar takes over the strategy, but it's not exactly his strategy, but he can still explain exactly what Bob did. Their strategies are similar. And Oscar talks 11 times in the whole group. So this is part of our data where we're like tabulating how many times people share. And that big line is so this intervention. So day 1, day 2, day 3, he had this blue is you share a strategy. Red is somebody is talking in the whole group about your strategy. And yellow is that you're engaged in other peer strategies. So you're talking about what other students do. So before this, he was talked about once. His strategy was talked about once in class. But after this, that first day is that many strategy shares, 11 times he talks in class, but way more of the other students talking about his strategies, right? So now he's part of the conversation. His ideas are respected. And so when we're thinking about universal design for learning, this is what I'm thinking about. Miss Ray noticed the barrier. She noticed not what was wrong with Oscar. She noticed how the class was not working for him. And in this case, she felt that the class he needed a co-share. She needed to remind all the students around him that it's their job to talk and engage with everybody. And she needed to kind of design the conditions a little bit so that he could co-share, right? So that he was sitting next to somebody he'd be comfortable with. And that opened the classroom up for him, but also provided supports for him. I think having Bob next to him was a support. I think having her ask him to share, those are supports that she added. And so I see her doing all of these things, but even more specifically, I see her trusting in students' thinking. I see that she fought to include all students in her math class, in her class in general, Miss Ray. She built relationships through strengths. I forgot to tell you this part of the story, but she really developed her relationship with Oscar. He loved space. And so she brought in space books at the beginning of the year, and she would show him the books. She kind of like show him. And at first he didn't really engage. And then he brought in his books to show her, and their relationship bloomed from there. It's all about books about space. She allowed him to enter and take risks. To think of a student with autism first share in a math classroom to be about a time they made a mistake and to feel great about that. And for that to be like a valued thing, that's an amazing community that she's built there. And that community supported Oscar to share. So she made sure that everybody had access to grade level mathematics. This is not about filling in some gaps from before for either Daniel or for Oscar. This is about engaging them in that work of the grade they should be doing. It's about flexibility. She doesn't care how they solve the problem. Solve it however you want. Make sense of it however you want. That is very accessible to all students. Kids should always have the choice of how to solve problems, I think. Always. Some kids should always have the choice. For you to say, wait, I need you to solve it this way that I'm thinking, there are some kids that is really hard for. So a simple way is to always have the choice. We can ask them to, we can say, oh, it would be nice if you tried this. That's fine. But make sure we're not sending home homework that means there's just one way to do it. That does not work for all of our students. She gave support through this idea of revision, changing our thinking, redoing. And she was always trying to make her classroom better. And lastly, when we talked about this at the very end, I had her read all my field notes. I had her read all of the analysis that we had done as a team. And she, at that point only, told me that when she was a child, she had been pulled out for speech and language services. So that's why she was so committed to his inclusion in the group. That's why she fought to have students with disabilities in her class. And that's why she always made sure they had access to the highest level thinking of the class. And that's about empathy, which is core in design, which is core in doing any of this work. So I want to return to that question. How do we establish and support equitable mathematics learning communities in which students, especially those who have been historically underserved? And here we're talking about two students, one who is Latino with autism, another who is Latino, who has dyslexia, and is a multilingual learner. These are students who have very much been misserved by our schools, who's in their intersectionalities, they've sort of been not taken care of, not supported, not trusted to be the amazing sort of gifted mathematical thinkers that they both are. So how do we help them to develop positive identities and agency, make sense of mathematics, and know that their ideas are important and their voices are heard? And I think Ms. Ray did a beautiful job with that. So in my book, half the book is stories like this from teachers doing really amazing things. Like this is a teacher, Hannah, who's in a K-1 special education class for students with significant support needs, students with autism, and she does accounting collections work with them. This is a teacher doing a thinking classrooms task in her inclusive second grade. This is a teacher, Dina Williams, doing a number string with her inclusive second grade class. This is a seventh grade teacher in one of my research projects who is sitting down with a student who does beautiful visual patterns tasks with their kids. So all different curriculums, all different ways of doing it. But teachers like yourselves, like probably on this call, you should contact me because you're doing amazing stuff and I should know about it, right? Because I love that. All right, we're not going to talk about that. All right, let's do questions. Sorry, don't look at it. We can't talk about it. All right.
Thank you, Rachel, so much. Thank you for inviting us into Ms. Ray's classroom so intimately. We are going to start our Q&A portion. We have actually two questions that have come in. One that's more like a teacher, coming from a teacher, and one from a coach. The first question is, in my class, as a classroom teacher, what is your suggestions for ways to start changing the culture in my school around supporting students on IEPs in math?
So I guess I need to know what the culture is in school, but let me draw on my vast experience of being in schools in America. So often students with IEPs, like we learned from those first two narratives, are just not given access to sense making in mathematics because there's an assumption that students with disabilities need to have explicit instruction or need to have things modeled for them or will become confused with multiple strategies. And we do have research evidence that those things are not necessarily true. And we also have a ton of research using explicit instruction for those students. So it's a complicated situation, but the basic idea is that all students should have access to grade level math, and all students should have access to a curriculum that allows them to make sense of it for themselves. And I'm a really big advocate for that because kids need to think for themselves. So when in a school, for example, when we have special educators, and as a special educator and as a general educator, when we're thinking about things like from like a way high up, like this student needs this kind of teaching, this student needs this kind of teaching. No, we need to do inquiry based. No, we need to do explicit instruction. When you start at it like big and different, there can be arguments, there can be disagreements, because you're really having an argument that the people in like who write research or whatever, they're having. But really down at the classroom level, where the places of collaboration are, is when you, for example, look at a kid's thinking. So if you take a kid and look at their work, like look at Oscar's work, look at Daniel's work, look at Kalani's work, that's when collaboration really starts. You have to begin with the immediate and try to avoid big conversations, because it will often turn out that you agree a lot more than you think you agree when you're talking about specific situations. So that's the first thing I would do. I would look at kids' work. I would think about how kids are learning and what we need to do in particular classes to adapt those kids, to adapt the classroom for those kids, and how those adaptations in true UDL style can work for everybody. Like what the things that Miss Ray did for Oscar helped everybody, because she was just talking about, let's increase discourse in the classroom. Let's increase our comfort with making mistakes, right? So that's what I would do. I would do collaboration across special education and general education, and I would really begin by focusing on kids. And if you really want to be amazing, I would decide on a barrier that you want to redesign collectively. So say, for example, this was Miss Ray as a team, and they looked, maybe they didn't have all the analysis like the counting that I did, but they can generally get a sense. Okay, a barrier right now is kids not, some of our students with IEPs are not engaging in the discussion. What can we do? Let's talk to them about it, see why they're not. Let's try something and play with it and tinker and see if we can make it grow together, like as a team, like with all of our strengths together. So that kind of collaboration is what I would recommend.
So, and Rachel, there's another question that came in from Michelle. So along the lines around, what are your ideas for students who do not have access to the mathematics because of their foundational mathematics, not just their math facts, but number sense, structuring, etc.?
So it's never completely true that a student doesn't have access to what's happening in the grade level. It's always partially true, if you know what I mean. So like if I tell a story in the book about a student that was in my class in the 5th and 6th grade class, and this particular student had something called Williams syndrome, which makes math extremely hard. And she actually had been in a Catholic school before she came to me, so she knew all of her algorithms. She could add, subtract, multiply, and divide, but she had no access to conceptual understanding. She was just drilled in those things. So there were a lot of things that she didn't have access to in the classroom. And so I would have to figure out how to make the same idea create access for her. So I remember we're doing a lesson on volume. And so I made sure that I had cubes and that everybody was using them. And I gave a volume problem that had to do with 60, or you could make a choice. Like I gave number sets and I made sure that 12 was there, because she had to make it each time and she had to make it and keep it. Like she couldn't make it and then hold it, because one of the differences you have with Williams syndrome is a really hard time remembering like numbers, keeping things in your working memory. So she would make it and then look at it, make it and look at it. She needed that to think about that concept, but she was able to then get access to the concept. So there's always a way. As kids get older, it gets a lot more challenging. The most important thing is to remember that the tools that will allow them to have access are typically visuals, representations, choice on how they're doing it. I love the idea of different number sets or different choices in like the numbers you're going to use in a problem, but the kids pick them themselves instead of us giving it to them. This is like child-led differentiation, which is really important. And then if you have students who have, for example, like significant intellectual disabilities, which this student had with Williams syndrome, you have to know what it is you're going for. She was not going to learn every single thing in the 5th and 6th grade classroom. She was not going to hit every standard. That's a ridiculous expectation. But what I wanted for her to have was access to sense making, access to ideas, and really a chance to think. And the way she thought was through objects. So I found that when she had objects, she could think, and I had to think in my head, what is my goal for her today? My goal for her is to talk to her group. My goal for her is to think about volume and to count volume in small amounts. And that's how you would create access, right? But you also have to do this in a way where it's not like so much, like I had multiple kids who had pretty significant disabilities in that class, and I couldn't individualize what they were all doing every day. So I had to find ways that worked across more than one kid. And so, for example, open choice of manipulatives, open choice of strategies, highly visual, relatable problems worked across many different kids, right? They're just, it's useful because more kids are engaged, more kids are involved, they're grabbing tools. It's not like just that student is grabbing tools. So it's about accessible tools. It's about knowing your goal and figuring out what part of that you want to make sure that student has access to that day.
I want to squeeze in one more question here from Amy B. So how do you propose, advise changing or shifting systems to support students that need to move through a lesson or a topic at a reduced pace when there's a timing component dedicated by the curriculum or department or district?
So this question gets at the absolute issue, which is time. The time is the biggest issue for students with disabilities. When I've done interviews with kids, when I've looked at like memoirs across many memoirs, I did a study like that. Time. Kids with disabilities were like, I need more time. I need more time. I just need more time. I can learn. I just need more time. That's what the kids were screaming through all of these ways, right? Then as teachers, time is our issue too, right? We're like, we can't engage them in this in the same time. There is a constraint of time. It is mathematically impossible. We can't do everything at once. So it's the slide that I skipped over. See, now I regret it. So that slide is about how we can think about math as a ladder, right? Like you got to learn everything before you go on. There are some things you have to, like a ladder is not useful here because students who are neurodivergent often struggle with easier things and then are better at higher things. So for example, look at Daniel, both Daniel and Oscar having trouble counting. That is not atypical at all in my experience. They can do complicated fraction problems, but they're going to miscount more often than other kids. And that's just part of it. So you can't wait until they count perfectly to allow them to move on. You have to, that's why the grade level thing is so important because if kids do not like perfectly develop in this kind of like linear way, then when you wait until they're good at this, you are like completely diminishing their opportunities to be really good at algebra because that's going to be their magic moment, or geometry because that's the time they're going to totally shine. So we have to make sure that we're always giving them access. And then, okay, so I'm so distracted right now. Okay, so then that's the ladder. Then you can think of it as a web, and a web is beautiful, but sometimes there are things that kids need more than other things. Like a web doesn't show us what's the most important thing. So the last metaphor that I think has been helpful for me and some other people is the idea of mathematical learning as like a building. So you know how you can't knock down certain walls because they're load-bearing walls? Like I was doing my house and they're like, you can't knock down that wall. It's a load-bearing wall. In math, some walls can be knocked right down and the kid can still grow. And there's certain walls that you can't knock down. So if you think, for me, fractions, understanding fractions is like, I think, a load-bearing wall because you can't hand a calculator and fix that problem, right? You need to understand fractions. So in terms, to get back to this person's question, kids are not going to learn everything in a year. Teachers shouldn't have to teach everything in a year. You have to figure out what is the most important things, what's worth your time, what's worth the investment. And to include kids with disabilities in your class, all the more so, you need to spend time on what matters. You need to know that fractions are worth it. Like fractional understanding, multiple representation of fractions, fair sharings, it is worth it because it matters later for them. And because it's very hard to put something in place to hold that wall up if it's not there. Subtraction with regrouping, that's not a load-bearing wall. If they understand place value, they understand subtraction, then you can hand them a calculator. You can knock that wall down. Maybe that was really confusing. It would have been better if I had shown the slide, but I didn't, and I'm just going to be okay with that.
And it was wonderful. Thank you. So Rachel, we just want to thank you so much for your insights on trusting students and creative and inclusive and supportive environment in math classrooms. I'm going to share. So, we are grateful to our forum colleagues and the nationally recognized educators and researchers who have dedicated their time and knowledge to help us build more inclusive and supportive math classrooms. Thank you to the incredible speakers for sharing their expertise and insights during the 2024-2025 speaker series focused on the elements of equitable math learning communities. If you missed any of the events, don't worry. Each session is available for you to revisit on the speaker series page of the forum website. We hope that you will take a few moments to explore the website and the resources it has to offer, including the related work page, where you will find more information about the work featured throughout the speaker series. As we look ahead, we're excited to begin planning for the 2025-2026 speaker series and hope you'll continue to be part of this community. Stay tuned for more details, and we can't wait to see you at our future events. On behalf of the forum, thank you for joining us tonight.